Good morning. It's Tuesday, Jan 28, 2025, Advanced Topics in Data Storage. We'll start today's lecture on Introduction to Python. Yep. So we stole this lecture from Perspectives on Data Science class. Uh, Let me check if I'm recording. Yes, I am. Okay, cool. So if someone is there in Perspectives on Data Science class, you're free to leave the class because it's if it will get bored for you to listen the class twice. If you want to be, you can. But for attendance, just get your WSU IDs to the professor right there. If you are in PDS, or if you want to stay, you can stay because it's like different lecture. I mean, same lecture but different persons teaching, so it may be different. Yeah. So meanwhile, let's start our lecture. So we stole this from PDS, Perspectives on Data Science. So it's the same lecture, Introduction to Python. So why are we learning Python? There is ChatGPT, which makes our lives easy, right? Let's see. Let's open ChatGPT. Open AI. Try. Can you code? Can you write a code for me? Yeah. So it tries to write anything. I mean, if we ask a code in Python, or if we ask a code in C, if we ask a code in Java, it, it gives the code for us. So why are we still learning Python? So what's the point of learning a programming language if there is something we can get? Um, there is something that can give us the code, right? For example, write a code for palindrome in Python. You can even go details like I am using Jupyter notebook, for example. It's giving us code. It's giving us code in Python, but still we are learning because even ChatGPT is made out of Python. It's a large language model. Someone is typing in chat. So if you guys online have any questions at any point of time, you can just type the chat, or you can just ask me to stop and you can question. I mean, you can ask the question. So we have this chat GPT. We are writing code in chat GPT. It's giving us the code, but we're still learning our code because this was made of Python. It's a large language model. And it's okay if you are master student, we're just learning the stuff. But if you're doing a research, you are doing the stuff. So we just don't use the pre-built libraries in Python. We'll just try to create new algorithm. Then we just need a code to write. And it's always a good thing to learn coding because you know, we we can do we can tweak our stuff. We can tweak whatever we need. Like you know how to write a loop. You know the logic. Then you can just use the programming language to code. So it's not always a good idea to depend on AI models to write the code. At least know your basics. You can tweak your stuff when you go to advanced level. So first, how you write your code. We need something to write a code, right? I mean, we need some compiler to write a code. So in this class, we encourage you to use Jupyter Notebook to write your code. So this is the toolbar for Jupyter. It's how you save the file. You can go into file and save as, and you can save it as PDF, HTML, or IPYNB file, .py file, or anything. You just need to add a new block. Just press plus key to add a new block. You can just cut, copy, and paste your stuff. You can move your block upwards or downwards using these arrows. You can just try to execute your code using run block here, and you can stop at any point of time. So when you're trying to build a model in data science, it's data storage class, but if you are running a data science project, you're trying to run a big model. It's taking a lot of time. You just want to stop the model and change the parameters of the model going back. You can just use the stop right here. It just stops the execution of the code then, and you can go back. You can retype your parameters to make it work faster. I mean, you can increase the step size, or you can increase whatever you need. Yeah, you can reset the block and clear the output. It's a markdown. So if you want to write the code, you can just get code from the markdown window. And yeah, that's useful if you want to write something in the middle of your notebook. Yep, that's basically about Jupyter toolbar. So when you just open it and try to try to go to all the options right there on the top. You'll have a lot of options inside as well. So you can just play around with the notebook once you install that. But when you're trying to install Python in MacBook, so just be careful, because MacBook itself is made with Python. So Python with versions changes the code. So Python 2 code won't be compatible with Python 3 code. So just your MacBook may be using 2.x and you are downloading 3.x. Just don't try to change the system Python there itself, because you may get error with your entire MacBook. So just try to be careful when you're trying to download and use the Python in your Jupyter notebook for Mac. And Google Colab, it's again one of the tool you can use to write your Python code. So good thing about Colab, if you're working in project if you're working in teams for a project, you can just use Colab, to work together in a single notebook. So it's very useful. And one more good thing is you can fix a RAM over there. So when you're using Jupyter notebook, it's using the RAM in your system. But whenever you're using Google Colab, you can just prefix a RAM to use. So it will be faster. It won't depend on your system. So it might be a little faster if you use that. Python. So it was invented in Netherlands in 1991 by Rossum. So open source from the beginning. So when Rossum introduced Python, he open sourced it from the very beginning. So when he invented, he just asked the programmers to go into the code and try to tweak it and make it useful for people. So he just didn't hide it, but he just asked the people to tweak it to make it useful for all of us. So it's open source from the beginning. So it's a high level interpreted language, abstracts hardware dependencies, code evaluated on the fly. Yes, and it's hybrid interpreted Python bytecode, scripting system maintenance tools, and huge set of libraries in all disciplines. So basically, we'll have a lot of libraries in Python. So Python, so a lot of people created libraries in their respective fields. So if you are from data science, you can see a lot of Matplotlib, SciPy, scikit-learn, and a lot of libraries you can use. And that's very useful for data science students. So likewise, we have set of libraries for all the disciplines, because it's an open source and people try to be creative in creating new libraries and making it useful for the people. And it's not like writing a code in one operating system and downloading it, and we just can't use in other operating systems. It's not like that. If you have .ipynb file or .py file you have done in Windows, you can just share the code to your friend who is using Mac. He can very well do the same thing what you have done in your Windows with his Mac. So It's compatible. It's very compatible. Okay. So why is it Python? He's fan of snakes. No, he's not fan of snakes. So there is a movie called, what's the movie called, Professor?
Monty Python, the Holy Grail is
Yeah, so that's the movie. So he's a big fan of that movie. So that's why he named it
series.
Python.
There was like 5 or 6 movies.
Yeah. Oh, yeah. So it's Python is not a snake, it's a movie.
If you click on that link at the bottom, we're not going to make him do it, but
Yep.
if you do it later,
Yeah, you can just use this
show or
use this link to see
just
what's
go to YouTube, type in Monty Python.
yeah.
It's all right.
What's different ways to run Python? You can use IDLE loop, Jupyter, Spider, which we just told, Jupyter Collab, VS Code, and everything. Yeah, there are different ways to run the Python. Bugs. What's the term bug came? Where's the term bug came from? So first time, Professor no, because he made the slide. So the first bug is an actual bug. So when the first time the system crashed, they went into the system. It's a huge system. It's not like the system. It's a huge system when in the beginning. So they just crawled into the system. They just saw what's wrong. Why did the system crash? So they just found a small bug or like a fly. You can just see it on slide, a small fly. So it is on a relay. It stopped the system to work. So from there on, they took out the bug and repaired it. They call it debugging. So whatever we're doing now, we're calling it debugging if we are getting the system back to work. We're just calling it debugging. So the phrases came from the real bug because the first bug is a real bug. So there are three types of errors, not bugs, errors. It's system error, runtime error, semantic error, syntax error. It's simple. We have set of rules in every programming language. So if we do not follow the rule, the system will ask us to recheck it. That's called system error. So if we miss a parenthesis or if we miss a colon, if we miss a semicolon, the programming language throws us an error. So that's called syntax error and runtime errors. So these are called exceptions. We can handle runtime errors, which we're going to see in a few slides. So for example, if you divide a number by 0, for example, a equals 5, b equals 0. So 5 by 0, it's meaningless, right? I mean, it's infinity. We can't divide a number with 0. So it throws error. So that's what called runtime errors. There are a lot of runtime errors. If you go and code yourself, you'll find a lot of errors. Semantic errors. System won't show us the semantic errors, and it's the worst errors we could get because we have done the mistake. For example, sum of a and b, a minus b, it doesn't make sense, but system gives us a minus b. 5 minus 2 is 3. It gives sum of a and b is 3. It's an error, but it's our mistake. So we need to go back into our entire code and check where's the logic gone wrong, and we need to correct the error. So that's called semantic error. Runtime errors. So we told it 0 division error, division by 0. And yes, that's everything about runtime error. And here is list index out of range. Yes, this is the type of error we got because the lists 1, 2, 3, 4, 5. We have 5 elements and we are gonna print list of 5. It should be shown something, right? Why it's error? Why is it error? It should be 5, right? The answer should be 5, isn't it? Yes. So it starts from 0, 0, 1, 2, 3, 4. So if we are asking it 5, that means it's index. I mean, the element we are asking about the sixth element. If we are asking about list of 5, it's about the sixth element. So there is no sixth element. So that shows us an error. So that's called index out of range error for the list. And key error, my dictionary equals A1, B2, and we're asking about the key C. So this is called key values, which we're going to see later on, but there is no key called C. We haven't assigned anything C to the list, I mean, to the dictionary, sorry. So there is no C in the dictionary, so that's an error. That's a key error. We're going to see dictionaries later on. And there's an attribute error, int num equals 10, num dot append of 5. Int object has no attribute append, because for we have append for lists, we don't have append for integers. That does not make sense. We just can't, we just can add integers to list. We just can't add integer to another integer. I mean, we can add, but we just can't append. So that's attribute error. We just can't make append for the integers. And import Thomas. So import, as we said, there are a lot of libraries. Every respective field has a lot of libraries associated to that. So people are creating libraries to use later on to make our lives easier. So what happens if there is something like no meaning to import? So that's where you get module not found error, because there is no library named Thomas. We have library named this. You can just type import this, and you can just see what it's gonna give us output. Okay, so if you want to play, you just import this and see what it gets. File not found. If there is no file on your system, and if you're trying to read a file, then it's file not found. And overflow error. So this is interesting, like occurs when the calculation exceeds the maximum limit of a numeric type. So every numeric has a limit. I mean, every type has a limit. You can just Google it to find the limit. If it's exceeding the limit, then it's like math range error. So this is called over and under something. Memory error. So when your program runs out of memory, you will get memory error, recursion error, maximum recursion depth exceeded. So there are a lot of errors. Just skip. And let's see. Hello world. That's correct. Hello world. That's correct. Because Python doesn't mind. It's your mistake of doing WRLD. It's not a correct spelling. So Python doesn't care if it's correct spelling or wrong, because it's you who are doing it. As long as it doesn't have any mistakes writing the code, you won't be getting error. That's simple stuff like in any programming language. Here the syntax error says string literal. Yeah, there's a lot of errors I can see here. I mean, it hasn't started with a colon right here, and it ended with a colon. So it's a syntax error, even though your spelling is correct. And print sum of A and B, that's semantic error as we discussed before. And unbound local error, cannot access local X where it is not associated with the value. Again, let's see. Print X. So it's executing line by line. It's asking to print X, and we're defining X later on. So it's an error. Line interpreter. And error handling in Python, there are numerous ways to handle errors. One of the way we are discussing the process of managing and responding to errors or exceptions that occurs during the execution of a program is called error handling. Helps prevent programs crashes and provides meaningful feedback to the users. So handle exceptions. So 5 by 0 is an error. We just can't make it to change its math. Like instead of 0, we just can't as the system to make it 1, but we can just handle the exception. So 0 division error. So if it's pushing 0 division error to us, if we are writing a long program and it's just pushing an error, it's okay. We can understand the 0 division error, but there are some errors which we cannot understand after we just read the error. So in that case, we can just use some of the meaningful sentences to show. So if this error causes, just show me like the number cannot be divisible by 0, or the denominator is 0. So it's easy to understand if the system throws this type of exception, just instead of showing the red mark saying 0 division error, right? So there are multiple exceptions, multiple ways to handle exceptions. So one of the ways to write in try except, try this one, except value error. If there is any value error, so invalid input, please enter a number. And there is another exception, 0 division error, cannot divide by 0. Instead of showing 0 division error in red mark, it just shows cannot divide by 0. It's easy. So you can handle multiple exceptions in the same code. So that's what here the slide tried to explain, using to except. So for one try, you can use to except. Okay? So using else and finally. So what's else and finally? Executes if no exception occurs. So if there is no exception, then the else block will execute. But finally, we'll execute even if that got an exception. Okay. So no matter if you got an exception in the code or not, you will you will see the finally getting executed. So if there is not file not found error, else won't be executed. File read successfully won't be executed, but finally block will be executed. If you write a print statement in finally block, it will show even if the file was not read properly, it will show file read successfully, because irrespective of the except block, finally will be executed. Okay. So keywords in Python, a lot of keywords in Python, like many other programming languages, C, C++, Java, we have same keywords in Python as well. You can see the list, total number of keywords in Python, 35. You can go through the things to know about the keywords. Variables in Python. Variables are used to store the data that can be referenced and manipulated during program execution. Unlike many other programming languages, Python variables do not require explicit declaration of type. The type of the variable is inferred based on the value assigned. So if we go back to C, C++, Java, if you just say it like a equal to 3, it will throw an error because we need to specify what the type of the variable that should be, like int a equal to 5. But Python is smart enough, it recognizes itself. Like if you type in like a equal to 5, it recognizes that it's an integer. So it's smart enough to recognize the integers. It's smart enough to recognize the strings. So there is no need to specify the type of the data, type of the variable, it recognizes automatically. Like not like C, C++ or Java, you should give like int a equal to 5 semicolon. You can just give like a equal to 5. It will know like that's an integer. Yeah. So rules for naming the variables, like every other programming languages, we have certain rules. For Python, to name the variable, because you can't name it with a keyword, because that's a contradiction. If you are using keyword and if you are naming some variable as the keyword, so that basically doesn't make sense, right? So we have some rules. It shouldn't be a keyword first. Next, to use variables effectively, we must follow Python's naming rules. Variables can only contain letters, digits, and underscores. No special characters allowed while naming the variables. And variable name cannot start with a digit. Correct? It can start with an underscore, but it can't start with a digit. So variable names are case sensitive. So lowercase a equal to 5, uppercase a equal to 5, both are different. So whenever you write uppercase A6, lowercase A5, if in the code, if you're calling lowercase a, that's gonna be what the value you assign. So it's case sensitive. Avoid using Python keywords as we discussed before. Valid variable names, invalid variable names. Current underscore balance. You can use underscore, but hyphen is a special character. You can't use that. Current balance, yes, it's correct, but you can't have spaces in between. So keywords only contains what? Alphabets, underscore, and numbers. That's it. And again, it can't start with a number. Account 4, yes, 4 account, no. Underscore 42, you can do that, but you just can't name a variable just starting with a number, no. Total underscore sum, yes, and dollar is a special character again there. And you just can't have colon, anything special characters in the variable name, so it's again mistake right here. A equal to 5, b equal to 10, 4 account, that's a wrong variable representation, so it's gonna throw a syntax error because that's a rule you need to follow. So there's a mistake in rule, so it shows syntax error. Lambda 6, print lambda. Lambda is a keyword, I guess. Yes, lambda is a keyword, so you just can't use it as a variable name. Operators. Yeah, like every other programming language, we have operators in Python as well. Arithmetic operators, bitwise operators, logical operators, assignment operators, identity operators, special operators, many more. Let's see arithmetic operators. What is arithmetic operators? Plus, minus, I mean, addition, subtraction, multiplication, division. Let's see. Addition, it's simple plus. Subtraction, it's minus. Star or asterisk, it's multiplication. Slash, division. Modulo, what's modulo? We discussed in the first lecture. Yeah, it's the remainder. So if you're doing like 3 mod 2, I mean 3 divided by 2, the modulus is 1. Right? Again, floor division. You know what's floor division? It doesn't show us the decimals. Yeah, decimal values here. It's exponent. We're using double asterisk symbol out there. 15 power 4. PEMDAS. In German, we call Punktwurstrick. That's how we spell. Yeah. So Python precedence of operators generally follows PEMDAS, BODMAS, BIDMAS. So whatever your elementary school taught you. Yeah. Be aware of unary, BODMAS maybe. Explicit parentheses, avoid confusion. So this is how the precedence for the operations going on, like parentheses, exponents, multiplication, division, addition, subtraction. So it's not like multiplication ahead of division or addition ahead of subtraction. It's all like, you know, multiplication, division got the same precedence. It may be D and M interchangeable and A and S interchangeable. Okay. So that's one thing you need to keep in mind. It's not like first do multiplication and then do division. You can do division first and then multiplication. M and D got the same precedence. Yeah. So that's the mistake most of us do. Comparison operators. You can compare the operators, whether it's small, I mean, whether it's less than the one variable or greater than the other, or equal or not equal, anything. You can go through the example right there. Logical operators, we discussed in our last lecture about and, or, not. It's simple. If A is true, B is false, how's and, or, and not gonna work? It's simple logical operators, and we're going to use the logical and bitwise operators a lot in our advanced data storage class going on, because everything is logical in RAIDs. So as we've seen, we're just doing like even and odd parity. So it's like counting number of ones and saying if it's even or odd. So even there will be a lot of in-depth mathematical stuff we need to do going on into the classes. So it's better if you are familiar with and, or, not, and XOR and everything. So these bitwise operators, you can play around with the bitwise operators as well. And what's happening with A right here? It's binary not. Okay. So A is 10, that's 1010, and it's giving us minus 11, 1011. So anyone has any idea what's going on in there?
Yes, so what's happening is it's flipping all the bits.
Yep.
And then if it's not a signed integer, it's then taking those bits and reinterpreting them as a signed integer, which means that there's this extra. I was messing around with it during the last class, trying to understand why it's not flipping correct or what you think it's going to do, but really what it's doing is it's flipping to the one's complement.
Yeah.
And then since that number is actually an unsigned integer, it turns it into the two's complement representation. If you have that as a uint number, which we're not going to mess with that, but yeah. So if you're messing with bit strings and not messing with integers, then the tilde will actually just flip every single bit. If you're messing with an integer, it'll flip all the bits, and then it will convert it into the two's complement representation of what the number discrete was, which is confusing.
Yeah.
It makes sense. You understand what you're trying to do. You're trying to negate the number, another way of negating it. So
every time you do something, I mean, you do program something, you just try to understand what was going on. Just don't simply
like. This is an example where the actual, you know, the underlying machine implementation.
Yeah. So
It's
it's
actually exposed to people, even though it's a high-level language, you can't hide the low-level stuff.
yeah. So programming is nothing but doing mathematical operation. So understand how it's going on in the back so that it will be useful for you later. Yeah. Assignment operators again equal to, I mean, equal to is an assignment operator. So plus equals, it's assigning some value to a. So a plus equals is nothing but a equals to a plus, right? So it's assigning a some number, some new number. So it's an assignment operator. Minus equals, everything is an assignment operator if it has equal to in it. Identity operator. Examples of identity operator. Yep. A is B, A is C, A is not B. So here A is 1 to 3, a list. B is another list, 1 to 3, the same list. And we're doing like C equals A. We're duplicating A into C. We're just inputting the variables A, I mean the list A into C. And we're just saying print if A is B. I mean we're asking A and B are equal or not. I mean the same or not. So if you are familiar with Java, we have a memory operator over there, right? I mean star. We'll use star. I forgot Java. It's back like 3 years back. I used Java 3 or 4 years. So no man. So star. So it's the memory. It's pointing towards the memory. So that's something you can. It's not Java. It's C, I guess. It's something you can understand it from there. So A is B false. A is not B. It's a different thing. It's a different thing. It's a different string. I mean, what string? It's a different list and it's a different list. Okay? So A is not B. B is not A. Okay? C is A. Yeah, it's the C is also pointing towards the memory with A. So C is equal to A. So A is C, true. But A is B, it's false. B is not A or A is not B, it's true again. It makes sense, right? Any questions in this slide? Yeah. Membership operator. Check if a value exists in a sequence like a string or list. Examples of membership operator: 2 in A, true; 5 not in A, true. So good thing to understand here: in and not in. In means there's something inside that. Not in, there's not there. So it just returns true or false if it's true or false. Okay. Statements. So Python statements are the instructions or commands that the Python interpreter executes. They are the building blocks of Python and define what the program does. Here are the major types of Python statements. So it's a statement, hello world. What's the hello? Sum of 10 and 20 is 30. Yep. We're just printing hello, comma world, and we're just assigning 10 and 20 to x and y respectively, and we're just adding it. And this variable assignment a equal to 5, b equal to 10. We're assigning something to the variable. So it's just what we discussed before. Conditional statement. So a good thing about Python. So if you check any other programming languages, there is loops starting with parentheses, starting with braces. Good thing about Python, it's just the um, indentation. So you see here, there is a space between the start of print and before that you see the tab of space. So whatever you write starting with P, everything goes under the same loop. So it's not like doing parentheses or we're not putting any braces. We're just putting a column. So that means the loop starts over there and there is some space. So whatever you write starting from there, so everything will be under the loop. If you see any other programming languages, space doesn't really matter. Indentation doesn't really matter, but Python matters. You take care of indentation when you write a code. Yeah. You can again adjust the indentation in your compiler, like giving 2 spaces or 3 spaces or 4 spaces, whatever. You can just play around when you go into the tools provided in the compiler. So the space, the number of spaces we give doesn't matter, space matters. Okay? So functions. Functions are used to organize code into reusable blocks. Simple, it's def. So we'll write the function using the keyword def. So wherever you see the keyword def, that means there's a function. where you can use the function later on in your code. So we're just defining a function. We're just using the function again and again in our code. That's basically about function. Loops, again, we just discussed for loop and while loop. So there are two different loops we're discussing here, for and while. There's an interesting difference between for and while. What's the difference between for and while, anyone? So that's just doing the same thing, right? Here. So what's the difference between for and while? Yeah. And while is also doing the same thing. Range. So
we need to assign a number to a
correct.
variable, and we need to increment the variable.
Correct. So for loop auto increments, and while loop we need to manually increment stuff. Correct. And one more difference. So if you are seeing for loop, so first I execute. So even if it's not in range, it goes into the loop and it prints and then checks whether this next I is true or false. Yeah. So unlike while will not execute if the logic is not true, but for executes even the I is out of range for once and then checks again for the condition and then executes if the condition is true. If it's false, it just comes out of the loop. So for loop, whether the I has in the range or not in the range, so it executes one time. That's one more difference. It's interesting difference, and very few of us know the difference between. I mean, that thing. So for loop executes one time, no matter if the I is out of range. Classes and objects. Class calculator. So inside classes we'll have attributes. I mean, classes define objects with attributes and methods. So result after calculation. So we're using class calculator. It has many functions inside that. So we are calling the calculator using calc, and we are just trying to call a function using the name of the class we just declared here, calc dot add, and it just do whatever the logic inside add definition, and it will just do whatever the logic inside subtract definition. That's simple. Import statement. As we said, there are a lot of libraries. How to use the libraries? Just import the libraries and use the functions inside the libraries. Use like import pandas, use pd.read underscore csv, pd.read underscore excel. Pd is nothing but we are just giving the name pandas as pd, import pandas as pd, and we're just using pd later on in our program. So we'll just import the libraries and use the functions inside those libraries. And exception handling, we just discussed exception handling. Return statement, it just returns. I mean, inside the function, it just returns. That's the same thing we do in other programming languages as well. Pass statement, it do nothing. So if we want to break the loop, for example, if you write a for loop, if there is any loop, we just want to pass it to the next block of code. We just use pass, it does nothing, it just passes. And break, just the opposite, it just breaks. Continue means it's continue. Global and non-local, same thing. Global and local statements. So global variable 10. So if it's declared globally, you can also use it inside the definition. If you have used it inside a definition or inside a function, you just can't use it outside the function because it's to that local. We have assigned it to the local, not the global. If it's global, you can use it locally. Yeah. That's the basic difference. If we go into here, global variable 10, global variable plus equals 5. So even if it's not declared inside of this thing, it's just using this thing right there. This global variable. We are just asking the global variable to be used from the global. So we just can't use anything from the definition outside of that scope. Del statement says again delete, used to delete from the strings, not strings. It's, I don't know why it's coming again. It's from the, what's that? arrays or anything. You can just delete it. Yeah. Next, data types in Python. There are a lot of data types in Python. You would need not to be explicitly assign it to a variable. You can just say a equal to 2, not like int a equal to 2, but there are a lot of data types we can use in Python: integers, float, complex, boolean, string. We have discussed list, tuple, range, bytes, set. We're going to discuss about lists, tuples, and dictionaries later on in this course. You can go ahead and try it yourself to use other operators as well if you are really interested to do that. And strings, yes. Strings are sequence of characters. So they are enclosed in a single or double quotes. Strings are immutable. What's the difference between mutable and immutable terminology? Yes. If you can change, it's called mutable. That's it. Yeah. So immutable we cannot change. Mutable we can change. That's the terminology we use here. Strings are immutable. We cannot change the strings, meaning they cannot be changed once created. So text hello comma world print text, it will print it. So this is how you write a string. So it's the combination of characters. That's it. List of characters is called strings. List is the collection of ordered and mutable items in Python. It allows storing multiple items of various data types. So what's various data types? What's the terminology for saying various data types? There's one word to say that: variable data type, various data types. It's on the slide. It's heterogeneous. What's the difference between homogeneous and heterogeneous?
Different types of data types data is stored in a variable is called heterogeneous.
Correct. Yeah. So homogeneous is nothing but single data type. Heterogeneous, multiple data types. That's it. So that's the terminology you should be aware of. And mutable, immutable, we have discussed. Ordered, it's in the name, order. So that's about lists. So that's the syntax you can go through. You can have multiple data types. So it's heterogeneous, we just discussed. One is an integer, hello is string. So it's heterogeneous. You can store multiple data types, okay, for a list. Tuples. Tuples is also heterogeneous. It's an ordered, it's immutable collection. Mutable means you cannot change it. Once you create the tuple, you cannot change what's inside that. It's again ordered. Is the syntax you can see on the bottom. Difference between lists and tuples. That's the basic syntax difference in the start. And mutable, immutable, and built-in methods. Lists support many built-in methods like insert, pop, remove. You can just use pop to pop and insert to insert. Just you can just delete it, you can remove it, everything. Tuples doesn't support. It's you cannot change it. Storage, memory efficiency. List consumes a lot of memory. Tuples consumes a lot less storage because we can time efficiency. Creation of lists and accessing the list element is slower. Creation of tuples and accessing the tuple elements is faster. Dictionaries again. Dictionaries is an unordered, mutable collection of key value pairs. We just discussed about key value pairs at the start of the lecture. So this is key. Name is called key. Alias is called value. So it's the new terminology. Key value. You should be aware when you are using dictionaries. We're assigning a value to each key. Yeah? So if we call it with a key, the value will be showed to us in the output. Okay? So that's what the example we showed at the start of the lecture. So keys immutable. Values can be any data type and can be mutable. You can change it. And unordered maintains insertion order as of Python 3.7. Mutable can add, modify, remove key value pairs. Why have we mentioned Python 3.7? As discussed earlier, the codes for every version of Python may change. So the rules may change. So Python 2, the same code, if you execute in Python 3 may not work. So that's why I made clear to you when you install Python in Mac, be careful. Don't mess up with the system Python. That's the example we just seen, and this is how we write. I mean, this is the syntax. We're assigning this thing to this. This is an assignment operator. This is how we name a variable. We have it's following the rules. It's the key. This is the value. Multiple data types, and colon. We're separating a key and value with colon, and every pair with a comma. That's it. Simple. Comments again. Comments are very useful in any programming languages, and there is no programming languages that doesn't support comments, I guess. Right? I'm not aware of any programming language that doesn't support comments. So if you are aware of any programming language, you know what comment is. So how to use comment in Python? So that's how you use single line. We'll just use hash, what they call pound key. Start with this symbol and write anything. Your code won't execute that thing. Multiple lines, it's simple. Just use triple quote, and it will comment multiple lines. That's it. Introduction to Python libraries. Yes, we have a lot of libraries as we discussed. It's just repetition. NumPy, it's a mathematical operation. We use NumPy for mathematical operations. So advanced data storage course, a lot of mathematical operators you need to perform. So you can just have paper and pen. You can just write numbers, and you can just use calculator to calculate. Then why to use programming language for calculations? Any idea? Why are we using programs for calculations when we can do it using calculator? Right. Yeah. So multiple reasons, like if it's a big program we are writing, we are just using a piece of code. We don't know the input. So the input is coming from other block of code. It's just executing that one and returning it. So, and not only that, so when there is not much of technology, so there used to be algorithms. They used to think we can do this, but they can't do that because of mathematical complications, because there is a lot of math going on inside. So it's easy for a system. If we give a code, it just executes the mathematical operations. But doing it on paper might be tough. A lot of variables, a lot of column names, and a lot of operations. So if we check for, if you are aware of stats, if you are doing eigenvalues and eigenvectors, so a lot of computations going on inside. So it's easy for us to solve for 3 by 3 matrix, and even we can go for 4 by 4 matrix. But if we have like a lot of columns and a lot of rows, if you are doing eigenvalues, eigenvectors, that should be a square matrix. If you have like, assume like 1,000 rows and 1,000 columns of matrix, so how are you going to solve it using pen and paper? It's easy for system to solve. We know how to solve, but we just can't solve it with pen and paper. And single value decomposition as well. You're doing the transpose and you are making the matrix into square and you're doing stuff. So that's against stats. Pandas. So it's just to load a data file. I think we don't use pandas in this advanced topics of data storage. It's the thing we stole from data science class, so we have stuff related to them. Again, matplotlib. This might be useful, how the data was, inside a file, how it's, distributed inside a file, or how a column is distributed, what's the min and what's the max, everything. You can just visualize using a matplotlib. You can have multiple plots like bar, pi, whatever you need. TensorFlow, it's again related to data science. That's a machine learning. We can just skip it. Scikit-learn, just skip. TensorFlow, skip. Skip. Because get HTTP is just for the collection of data. We don't want to collect data in ADS. It's for PDFs. Beautiful soup and scrap. It's good to know about this thing, because doing web scraping is a real thing now. So we just want to dig data from the websites. So for example, if you are seeing a post, the Facebook post, there are a lot of comments in there. So how is the Facebook removing the comments that's abusive? They are trying to remove that from the comment, but how are they doing that? So we can do that. We can just extract the text from the Facebook using Beautiful Soup and Scrapy. So that's where it's used. You can just extract information from a web page, uh, from the Facebook comment, from the YouTube comments, anything. So that's the real world application for using Beautiful Soup and Scrapy. Languages for data science, MATLAB. Yes, if you are going deep into the computations, just use MATLAB. It's easy to use and it's more computationally expensive, yeah, when compared to other things. So that's why a lot of data science students use MATLAB for the computations. SQL is again good to know for the ADS people because it's how we store, retrieve, or manipulate the data inside a database. So SQL is a good thing to know. I think we can also make a lecture or two related to SQL going on into further. I don't know if the time permits. SAS is again statistical analysis and data management tool. And languages for data science, yes, R is pretty much important if you are a data science, if you want to go into the data, because that's something computationally expensive as well, like MATLAB. So R shows more information. JavaScript is for web designing, and Python, what we're going to do in this course. So why are we discussing Python in this course? It's just like if we lost the data, how to recover the data, or if there is something mishappened in the data, how to recollect the data and how to change the data to original form. So we are dealing with this stuff. Why are we doing Python? I mean, why to learn Python in this course? Because if you want to build something virtually, suppose if you are going into the RAID and no, if you are studying about RAID and there are a lot of data blocks, and if you want to create a data block, every time you just can't buy a data and you just can't test it with, I mean, practically, right? You can do it virtually using Python. You can create a data block and you can input some arrays in there, I mean, data in there, and you can just play around with the stuff. You can create as many RAIDs as you need, and you can play around with that. So that's how useful for this class, the Python. Language for data science, Scala, Julia, Kotlin, Hadoop ecosystem. It's good to know about the history of languages for data science. That's for data science again. We were using Python. It's good if you know R. You can very well go ahead and use that. References to learn Python. You can go through all of these links given out there to learn Python. Google's Python class, W3 Python class, real Python class. And yes, we are on time. So it's 12:05 and there is 10 more minutes for quiz. So we are right on time. That's a good thing. Let me stop the recording.